Hello everyone, welcome to Formula Story. In this video series, I'll be teaching you all permutation and combinations in a bit of a simplified manner. This whole video series will comprise of about 6 to 8 videos which will discuss all the basic concepts and the applications which are there in permutation and combinations. So let's begin. Let's see the definition of permutation and combinations first. Permutation and combinations are the various ways in which objects from a set may be selected, generally without replacement, so as to form subsets. This selection of subset is called a permutation when the order of selection is a factor, and it is called a combination when the order is not a factor. Most of us might know this basic definition, so let's look at a few basic concepts as well. Now the first basic concept is, if there are two events, say A and B, and if event A can be done in m ways and event B can be done in n ways, then exactly one of the events A or B can be done in m plus n ways. So when there's an or in between, there's a plus sign that comes in. Now if you are asked, find the number of ways in which both the events A and B can be done together, then the answer would be m into n ways. So when there is an and in between, multiplication comes in. And another basic concept is, if there are n objects and they have to be arranged in n places, then the total number of ways is n factorial. Let's look at a few basic examples to illustrate the same. Now let's look at a basic example. Let's say there are 5 necklaces and they're to be given to 5 girls, such that each girl gets one necklace. Let's see how we'll solve this problem. It's an easy one. Let's just have a look at this. So let's say the 5 necklaces are 1, 2, 3, 4 and 5. And the 5 girls to whom the necklaces are to be distributed are A, B, C, D and E. Now the first necklace can be given to any of A, B, C, D or E, right? So there are 5 ways of giving the first necklace, right? Now let's say the first necklace is given to A. Okay, so A is gone. Now the second necklace which is to be given can be given to B, C, D or E. So there are 4 ways of giving the second necklace. Now let's say the third necklace is there, and we assume that the second necklace was given to girl B. So the third necklace can be given to either C or D or E. So 3 ways for the third necklace. Similarly 2 ways for the fourth necklace and 1 way for the fifth necklace. Now since the necklaces are to be distributed to girl A and B and C and D and E, so since there is an and, multiplication sign will come in, right? So it will be 5 into 4 into 3 into 2 into 1, which gives us 120. Now as we discussed previously, if there are n things which are to be distributed among n people, then that can be done in n factorial ways. Your n is replaced by 5, right? So the answer for this question should have been 5 factorial, which is 120 only, right? 120. So that's the same thing. This I've done just to illustrate the concept a bit better. So let's look at one more example, which is a slight variation of this example. Now the variation of the previous example is, in how many ways can 5 necklaces be given to 5 girls such that each girl gets one necklace and the first necklace cannot be given to girl A or B? The first necklace cannot be given to girl A or B. That's a slight twist in the previous question. That's easy to handle. Let's just look at it in a similar way in which we did the previous question. So let's say the 5 necklaces are 1, 2, 3, 4, 5. 5 girls are A, B, C, D, E. Now it's being said that the first necklace cannot be given to A or B, right? So the first necklace cannot be given to A or B. So it can be given to either C or D or E. So the first necklace can be given distributed in 3 ways, right? Let's say the first necklace which was given, it was given to girl C. Okay, so girl C is out. Now she won't get any other necklace. So now we've got necklace 2, necklace 3, necklace 4 and necklace 5, and we have 4 girls left, D, E, A and B. So we have 4 necklaces which are to be given to 4 girls without any condition. So as we know that if there are n things to be distributed among n people, then that can be done in n factorial ways. So since 4 is n here, so 3 into 4 factorial will be our answer. Right? I'll repeat. See, the condition here was the first necklace cannot be given to girl A or B. So the first one, the first necklace could have been given to girl C, D or E, right? So we assume that the first necklace was given to girl C. We can assume it to be anyone, C or D or E. We just want to remove one girl from the lot. Okay, so let's say necklace 1 was given to girl C. Now we've got necklace 2, 3, 4, 5, 4 necklaces left and 4 people to whom these 4 necklaces is to be distributed. So 4 people, 4 necklaces, that can be done in 4 factorial ways. So 3 into 4 factorial is our final answer, which will come out to be 24 times 3, which is 72. Okay. Now let's move on to further concepts of PNC. Now the questions that we saw up till now, they were the basic questions, which all won't see in the exams. They were just to understand the concepts. Most of the questions are a bit twisted. They'll have some condition or something attached with it. Now there are basically 2 types of condition which can be there in permutation and combination. It can either be a positive condition or it can be a negative condition. Positive condition will have keywords like must be, should be, etc. For example, there are 5 necklaces and A wants to wear necklace 1. That's a positive condition, that A will be wearing necklace 1. Now, a negative condition will have keywords like does not, shall not, etc. Example, 5 necklace and A does not want to wear necklace 1. So A does not want to wear the necklace 1, so that's a negative condition. The only thing to remember in such condition-based question is you always need to satisfy the positive condition first and then solve the question. So let's look at a few examples to illustrate this thing, whatever is being stated. Okay, so let's look at a similar genre of question wherein there are conditions attached, a positive and negative condition. So again, there are 5 necklaces, 5 girls, A, B, C, D, E, and A does not want to wear either first or the second necklace, and B wants to wear the third or the fourth necklace. So now we need to find the number of ways in which the necklaces can be distributed. So let's again consider that we have girl A, we have girl B, girl C, girl D. See, once you all practice, you all need not do all this. This is just for your understanding. Once you all are like through with all the concepts, this will happen automatically. Such questions can be done in like 10 seconds. Okay. So let's look, as I said, whenever there are conditions, we first satisfy the positive condition and then the negative one. So the positive condition here is that B wants to wear the third or the fourth necklace, right? That's the positive condition. So basically, B can choose the necklaces in 2 ways. B can either wear the third necklace or the fourth necklace. So there are 2 ways for B. Okay. So let's assume now, okay, that B has chosen the third necklace, right? You can assume it to be fourth one as well. We just want to remove one necklace for now so that other distribution can be done. So B has chosen the third necklace. Now the negative condition is stated that A does not want to wear either first or the second necklace. So A can't wear the first necklace, the second necklace, and since B has chosen the third necklace, A cannot wear that as well. So A can only wear the fourth or the fifth necklace, right? So A has got 2 choices. Okay, so A and B are sorted. We have satisfied the positive and the negative condition. Now we are left with C, D and E, and we are left with 3 necklaces, right? So 3 people, 3 necklaces, that can be done in 3 factorial ways. Now since A and B and C and D were to be given the necklaces, we'll multiply, right? See, I'll repeat. There were 5 girls, A, B, C, D, E. We satisfied the positive condition first, which was B wants to wear the third or fourth necklace. We assumed that B chose the third necklace. So B had 2 ways of wearing the necklace, 3 or 4. So we assumed that B wore the third one. Now we come to A. A cannot wear the first, second, and since B chose the third one, it cannot wear that as well. So A has got 2 ways, right? So let's say that A had chosen the fourth necklace. Okay. So now the fourth one is gone, the third necklace is gone. So now we have 3 people, 3 girls, which are C, D and E left, and 3 necklace, which is the first, second and fifth, which is left. So 3 necklace, 3 girls, that can be done in 3 factorial ways. We multiplied them all since there was an and, right? So this is 3 factorial is 6, 6 times 4 is 24. That's our answer. See, it's a simple concept which just requires a basic understanding, and once you all have that, it's really easy to crack such questions. Now, one question that might arise in your mind is, see, in this question, the negative condition was it cannot wear first or second, and the positive condition was it can wear third or fourth. Now, what if the conditions tend to collide? Like, it cannot, if the negative condition had the same necklace and the positive condition had the same necklace, then what do we do? In such a case, we need to make cases. So let's look at one more example which will illustrate this concept also. So let's see that when conditions collide, what do we do? Now, it's the same example with a slight twist in the same. 5 necklaces, 5 girls. A wants to wear the second or the third necklace, and B does not want to wear the first or the second necklace. So here the second necklace is common to the positive as well as the negative condition, right? So again, to explain, let's just consider these 5 girls again. A, B, C, D, E. As I said, we satisfy the positive condition first, right? So A wants to wear the second or third necklace. So let's make 2 cases. Case 1. Okay. Case 1 in which B has worn the in which A has worn the second necklace, right? So one way, A has worn the second necklace, right? A has worn the second necklace. So if A has worn the second necklace and B cannot wear the first or the second, so now B has got 3 options. It can wear the third or the fourth or the fifth necklace. There are 3 ways, right? Now there are 3 people left and 3 necklaces which are left. So that can be done in 3 factorial ways. Okay. Now let's consider case 2. When A chose to wear the third necklace. So one way, A chose to wear the third necklace, right? Now B cannot wear the first or second and also the third necklace because A has chosen the third necklace. So now B has got 2 options. B can choose either the fourth necklace or the fifth one, right? 2 options. And again, same thing. 2 necklaces are given to A and B. 3 necklaces left. C, D, E, 3 girls left. So 3 factorial ways. And a multiplication sign will come in both the cases. Right. So this gives us 6 into 3 which is 18. And this gives us 6 into 2 which is 12. Now see, either A can choose the second necklace or A can choose the third necklace. It cannot be possible that A chooses both the necklaces. So there won't be a multiplication sign, but there would rather be a plus sign. So it's to add the values of both these cases, which will give me 30. Let me explain this question again. So here we had the variation was that A wants to wear the second or the third necklace and B does not want to wear the first or the second necklace. Here we saw that the conditions, the positive and the negative condition were colliding. The second necklace was common to both. So as we know, we satisfy the positive condition first. So we assume that A has worn the second necklace. So B has got 3 options now. It cannot wear only the first and the second, but it can wear the other 3 necklaces. So 3 options for B. And let's say B chose the fourth necklace. Right. So now C, D and E ke liye we have first, third and the fifth necklace. So 3 ways, 3 people, 3 factorial ways. Right. That was a case 1. When A wore the second necklace. Now case 2 was when A wore the third necklace, right? When A wore the third necklace, B can choose either the fourth or the fifth one, because as per the negative condition, B cannot have the first, B cannot have the second, and B cannot have the third as well because A has chosen that, right? So B has got 2 options. Now again, 3 necklaces left, 3 people left, 3 factorial ways. So this ka total we found as 18. This value was we found as 12. Now either case 1 or case 2 will be valid. So or in between, which means there's a plus sign which will come in. So 18 plus 12 is 30. And this is how we got our answer. So people, these were the basic concepts which you'll need to know to solve major questions which come in permutation and combinations. Obviously we'll be doing more advanced concepts in the later videos which I make. But this was it for now. I hope you all understood all the basics properly. If you all had any doubt, do comment in the comment section. So that's it people. I will come up with more interesting videos in this video series. Till then, do like my video and subscribe to my channel, and also post your valuable feedback so that I can improve at my upcoming videos. Thank you.